guys, this is a continuation of paper 3. This is the GCSE 2019 past paper, and in this video we'll be doing questions 22 to 28. So here we have question 23 and we have a sketch of the curve y equals 2x. So this is our sketch, and 2x goes through 1 when x equals 0. And on the curve, we have to draw y equals 3x. So how do we start this question? What we have to do is substitute a load of values for x and then see what the y is. And then we do the same for this equation. So then we know that the curve is higher or lower than our original curve. So I'll walk you through how to do this. So the easiest way to do it is just taking some values of x. So for example, -2, -1, 0, 1, and 2. And then we substitute these values into this equation. So I'll show you how to do this and what I mean. So for this one, we have y equals 2. Then instead of x, we substitute -2. This gives us a value of, this is equal to 0.25. 0.25. Then we do the same with -1, so 2. We substitute -1 for the x. This gives us a value of y of 0.5. Then we continue, y equals 2, then we substitute 0. This is equal to 1. Y equals 2 to 1 is equals 2. And y to the power of 2, this is 4. So theoretically, if this is 1, so when x is 1, we know that y is 2. So we know that this value will be 2. We know that when x is 2, our y is 4. So 1, 2. So we know that this will be 4. And then the same with below. So when we have -1, we know that this value will be 0.5. -2, we know that this value will be 0.25. Obviously this is a very rough sketch, so don't take this as very accurate, it's just an estimate. So this is our y equals 2x, and then we will do the same for y equals 3x to see if the values are higher or lower and where we can draw this line. So let's start. So these values are for our y equals 2x, and then as I say, we'll do this again for y equals 3x. So we have x, y. We'll use the same values for x, so -2, -1, 0, 1, and 2. So again, we use this equation this time. Y equals 3x, y equals 3, we substitute x as -2. And this gives us a value of y of 0.111. And we continue. So these are values for our new line. So let's start with the 0. So we know that when x is 0, y is 1. So our line will pass through the same point as our other line, as we know that that is the same. Then we know that when x is 1, y equals 3, which is actually higher than this one. And then same here, when our x is 2, our y equals 9, this is again a higher y value than our other line. So we know that the new line will be higher than our y equals x. Y equals 2x, this is y equals 3x. However, we don't know whether our line will continue to go lower or continue to go higher. So let's see. So for y equals 2x, when x equals -1, our y is 0.5. And for our y equals 3x, when x is -1, our y is 0.33. So we know that this value is lower than this value. So we know that this line continues lower. And then same here, when x is -2, y is 0.25. And then for our other equation, which is y equals 3x, when x is -2, our y is 0.111, which is again lower than this value. So we know that this line will continue to be lower than our original line. So our line y equals 3x will go like this. Let's start with question 24. And we know that the length of the diagonal cuboid is 20 centimetres. So we know that this line is 20 centimetres, so we can mark that on our cuboid. And then the diagonal makes an angle of 24 degrees with the base. We already have this degree here. And then the area of the base is 150 centimetres squared. And we need to work out the volume of our cuboid. So we know we have the base of the, so we know we have the area of the base, which is a good start. And we need to work out the length of this line to multiply by the base to get our volume. So how do we get this line? We know that this triangle here in the middle, let's draw it out. So we want to find out this length, which is this line. We know that the longest line is 20 centimetres. And we know that our angle is 24 degrees. So this looks like a SOHCAHTOA question, so let's do that. So let's write out our SOHCAHTOA. So SOHCAHTOA. So we'll use SOHCAHTOA for this one. So SOHCAHTOA, and we're going to label our triangle. So we know that the longest line is the hypotenuse. So this is our H. The line just adjacent to the angle is the adjacent, so A. And we know that the line opposite the angle is the opposite. So we want to find out the opposite, and we've got the H, the hypotenuse. So we've got O and H, so O, and then H. So we know we're going to have to use so sin equals the O over the H. So we've got the sin angle, which is 24. So sin 24 times by the hypotenuse, which is 20 centimetres, will give us the opposite. So we know that our value of O will be sin 24 times by 20. So to get our volume, we know that this is the height of our cuboid, sin 24 times 20. And now we just multiply this by the base of the triangle, which is the width, and the length, which is 150. And that gives us 1,220 centimetre cubed. And that is our volume of our cuboid. Let's continue to question 25. Here we have a square ABCD. This square is just drawn on a simple graph here. A, B, C, and then D here. So 25A, a single transformation of A, B, C, D is such that B is mapped to D, D is mapped to B, A and C are invariant points, and we have to describe this transformation. So we know that the B is now here, we know that D is now here. So what happened here? So we know that the square couldn't have rotated because our A and C stay in the same position. So A didn't move here or here, A stays here. So it's definitely not a rotation. So if our B is now here and our D is now here, we have what we call a reflection around this point. So if you can imagine, our square just reflects like this. So our C and A stay in the same position, but it's just our D and our B that gets swapped around. So now we have B here, D here, A still stays the same, and C still stays the same. So what we can say is that we've got a reflection. However, we need to specify where this reflection is. So we know that the reflection happens here. And what we can call this line is y equals 1. As y equals 1 on this line, and that is where it gets reflected. So reflection on y equals 1. And that is our question 25A. So now we have a continuation of 25, 25B. Here we have a different single transformation of A, B, C, D. It's such that B is mapped to D, D is mapped to B, and the only invariant point is when x is 0, y equals 1. Describe fully the transformation. So let's draw the square again. So minus 2. So now this point will be D. Then we have a point here. We have a point here which we don't know what that point is. Then we have a point here which we know that is now B. Then we have also a point here, we don't know what that point is. And that is our new square. And we know that the only point that stays the same is the point here. If you rotate this triangle around the centre point once and then twice, you'll get our B here and you'll get our D over here and the B over here. It gets rotated by 180 degrees. So B gets rotated 180 degrees that way. We know that our C will be over here and our A is now here. So to describe this transformation, we just say rotation. The centre of rotation is this point here, which stays the same. So when x is 0, y equals 1. So centre is those coordinates. And then we know that it rotates by 180 degrees. So by moving here, this will be 180 degrees. And that is our question 25B. So here we have question 26, and we get 3 equations. So we have gx equals 16 take away x. Then we have a function of hx equals x cubed. And then we need to solve forghx equals 24. So what we do for this question is take our first equation, so 16 take away x is our gx. And we know that we need to substitute this equation, so the function of hx equals x cubed, into this equation. So this gives us 16 take away x cubed. So we simply just replace this x with this x, and that gives us a function ofghx, which is a combined function. So we know that this equals 24. So that's all we do, we plug this in, 24 equals 16 take away x cubed. We rearrange this equation for x cubed. X cubed will equal 16 take away 24. This equals minus 8. And all we have to do now is just cube root this. So our x will equal minus 8. And this is just minus 2. And that is our answer for question 26. So let's start with question 27. In this question, all lengths are in centimetres. So we have a point A on a circle with a centre O. So point A here, circle, centre O. Then we have a B point on a different circle with the centre O again. So our point B is here with the centre O just here. And then we know that AB equals 20. So we know that this line, A to B, is 20 centimetres. So let's start with this statement. So here we have the equation of the largest circle is y squared plus x squared equals 144. So the largest circle is this circle. So let's write this out. Y squared plus x squared equals 144. So we can use this as we know that y squared plus x squared equals r squared. Our r squared is the radius. So we know that our r squared will be equal to 144 in this case. So r squared equals 144. And then when we square root 144, we get 12 centimetres. So we know that the line from B to O will be 12 centimetres based off this statement. Next thing we do is look at the radius of smaller circle compared to the radius of larger circle. So we know it's a ratio of 4 to 5. So again, we take the radius of the larger circle and we use this ratio to get the radius of the smaller circle. So 12 times by 4 by 5 will equal a radius of 9.6 centimetres, and that's the smaller circle. So from O to A, this is the radius of the smaller circle, so we know this line is 9.6. So we can draw our triangle out so that we know what this angle is. So it's something like this. Obviously this is not accurate. 12 centimetres here, which is the O to B, and then B to A is 20 centimetres as the question stated, and then O to A is 9.6 centimetres. So we have all the sides, however we have no angles. So for this one we will use the cosine rule. So here we have our cosine rule. All we have to do is rearrange this now so that we are solving for the angle. So let's do that. So we have a squared equals b squared plus c squared, take away 2bc cos of a. So a squared, take away b squared, take away c squared, all divided by minus 2bc will give us the cos of a. I will just do swap the negatives. In our triangle we have B, C, and this is our A. So let's just plug those numbers in. So B squared, 12 squared plus C squared, 9.6 squared, take away A squared, 20 squared, divided by this by 2, times by 12, multiplied by 9.6. Minus 32 over 45 will equal our cos A. So now to get the actual angle, we do cos to the power of minus 1 minus 32 over 45, and that should give us our A. Let's put this into the calculator again. So this gives us an angle of 135 degrees. So our angle here will be 135. And that is our question 27. So let's begin question 28. Here we have Leo who runs for 12 seconds, and we've got a graph that shows his speed. So here is the graph. So we've got speed in meters per second on this side and then time on the bottom. And for question 28a, we need to show that the distance he runs is less than 67.5 meters. So we've got this odd shape here, and the easiest way to do this question is split this shape into other shapes. So if we go like this, we have our first shape, which is just a triangle. Then we split the remainder of the shape, so go like this. And here we have a trapezium. And then this sort of odd shape sort of looks like a triangle, so we can make this a triangle by overestimating its area. And this is our shape 3. So to find out how much the distance that he runs, we need to find the area under the curve. So we do this by, as I say, splitting the shape into 3 different shapes and then finding the area of those and then combining it together. So the first shape is just a triangle. So shape 1, we use the equation half HB will equal the area. This is just half the height of the triangle, which is 8, multiplied by the base, which is 5, and this gives us 20. Then we move on to shape 2, we have A2. This is the trapezium. So for the formula of the trapezium, we have A plus B. Our A is just this height here, which is 8. And our B is the second height here, which is 9. So 8 plus 9, half. And we multiply this by the size of the step size, which is 4. This gives us a value of 34. Then we move on to our third triangle. So we use this equation again. So A3 this time will be half HB. This one we use the height, which is 9, and the length, which is 3. This gives us 13.5. However, since this is an overestimate of this triangle, it is actually going to be smaller than 13.5. So then we add all these together. So total distance is 20 plus 34 plus 13.5. However, the total distance will be smaller because we're overestimating the area of the triangle. So 20 plus 34 plus 13.5. This gives us less than 67.5 meters. So that answers our question 28. Let's now continue with question 28b. We need to work out its average acceleration for the first 9 seconds. So our 9 seconds is just the first 2 shapes, here and here. However, we need to find the average. So let's look at the speed. The top speed that it gets to at 9 seconds is 9 meters per second. So we're working out our average acceleration. Then we divide this 9 meters per second by the time that it takes in, which is 9 seconds. And this gives us an average acceleration of 1 meter per second squared. And that is our question 28b.